Okay. So these were the operations on propositional variables that we came up with as of Wednesday. And we said the thing that was interesting was this or. Because this is our inclusive or. And what we wanted to try and figure out was if you really only get one or the other and not both, that should be a different column. An exclusive or should in English read like this. Because then that literally means you only get one of the two options. You are excluded from the possibility of having both. If I want to use this, I'm going to need to do symbol. Now, depending on your field of study, you can actually see this symbol in a number of different ways. The one I was taught was literally X or, X for exclusive. But symbolically, we often see a plus sign contained in a circle. That's the symbol our textbook uses. I think that's dumb, but I'll live with it. But then, Emily, I'm exactly where you wanted me to be on Wednesday. You can have one or the other, but not both. And or has two meanings in English. And that's why we have to differentiate this or from this one. Questions? Yes.
Third column.
This one?
No, the third column, the second exclusive.
That says XOR. P. This is P and Q, and P exclusive or Q.
So you can write that either an X or the circle with the plus inside of it?
Correct. And our textbook will use the circle plus symbol. So I didn't want you to look at that and go, what the hell is that? I wanted you to know, but I'm so used to writing XOR. As a matter of fact, I was taught formal logic for a different purpose. One we'll get to in a little bit. So as of this point, I now have four operations: negation and the two different versions of or. But if we're talking about math and logic, we're talking about putting together arguments. And one of the more interesting results is a conditional statement. All right, all you programming people, conditionals. What's a conditional? If is only half of it, if then. And quite frequently else, yes? But it can depend on the syntax of your programming language. So if P, then Q. Symbolically, we'll use an arrow. And that is normally read as implies. P implies Q. Those are all synonyms. So in English, it doesn't matter. Well, in our conditional statement, our if, the P part is called the name of this piece when it's set up for this format. Well, that's the verb that goes with it, the piece of the conditional. The propositional itself has to have a name in this form. In one sense, yes, but that's not the phrase we use here. Okay, so the condition we're looking at is the thing that that allows our implication to work, is the thing that comes before, right? So we'll call this the antecedent. Ante, before, right? It's also called a premise, or a hypothesis? Well, if that's the before, what's the other one? A result, an answer, something that comes after, right? So consequent, premise gets conclusion. So does hypothesis. So we have antecedent and consequent. Those are formal terms. If you use hypothesis and conclusion, I'm perfectly fine. If you use condition, well, we're going to read this whole thing as our conditional statement. So I want to be careful with that word. All right. This is a logic definition. Means I need a truth table. I'm going to run out of room. Let's add a new piece of paper. Okay. I need a sample statement for us to use. I need propositional variables so that we can try and parse this out in English and then figure out logic symbols. So I'm going to use these two propositions because each of those has a definite truth value. I study. Either you did or you didn't. There's a how much in there. We'll worry about that later. I do well on the exam. Your definition of well may be different than mine, but I did well enough is either you did or you didn't. If I study, then I will do well on the exam, is our conditional statement. So here's my question. I studied. I did well. Is the sentence, if I study, then I will do well on the exam, true or false? This first one right here. It's true. That makes sense. I study. I bomb the exam. If I study, then I will do well. In this case, what do I get? I should get a false. That makes sense. I didn't study. I aced the exam, failed the exam. Tell me about the contractual statement, the conditional itself. If I study, then I will do well on the exam. I didn't study. Is that a true statement or a false statement? Well, if it's false, is it false in only one of those bottom two rows, or is it false in both of those bottom two rows? If it's false in both of them, then this column reads TFFF, right? I already have that. Uh-oh. Now that's weird, isn't it? So I need to figure out why those should not both be falses. Emily?
They'd both be true.
Why?
Because if you don't do the condition, then the results don't matter because you didn't do the condition that you stated you would.
Aha. Think of this like a contract. If you study, then you'll do well. You didn't study, what happened to the contract? It never gets enforced, does it? If you don't start the process, what happens? Well, the contract's fine. We just didn't do it. And so that means that I don't know that this is false. And it ends up being true. No matter what, if you don't do the premise, the if-then statement, the conditional itself is a true statement. You're gonna love this one. If the moon is made of green cheese, then I am standing on the ceiling. Is true. We've been to the moon, it's rocks, not cheese. So I started with a false statement. If the moon is made of green cheese, then I am on the ceiling. Is a true sentence. Sure it is, Dr. Sassmore. You've been smoking funny things again? But that's the way this setup works. The other visual I have is a slide. I want you to picture a playground slide, right? Little ladder, little metal ramp thing, right? Now, you've all been on a slide at some point. If you climb up the ladder and you go down the slide is working, right? If you climb up the ladder and go down the slide works. If you go up the ladder and can't go down the slide is broken. What if you never go up the ladder? My default statement is, I'm not looking at the slide. It must be working. And that's why that's true. I see a person go to the base of the ladder. The slide is covered up. I see them come out the other side. For all I know, they went up the ladder and down the slide. That's a true statement. They didn't go right up the ladder. They lied to me. It works. Now, here's another problem in English. It shouldn't work this way. It just doesn't feel right. I wish I had a better rationale for it. In English, the words if and then are positionally dependent. And that means rather frequently, we have other ways of saying them. If you study, then you will do well on the exam. Do I need the word then in that sentence? We leave it off a lot, right? If you do this, I'll do that. I left the word then out. It's still in there, it's implied. Oh. You'll pass the exam if you study. That's the same sentence. I just put the clause at the other end. Page 7 of our textbook. There are 14 different sentences up here that all say the same thing. If P, then Q. But notice one of them is Q if P. You'll do well on the exam if you study. So the if tells me where things are. Until I see this one, P only if Q. The word only flips the roles of those two pieces. So I can't always just look at where's the word if. I gotta look around it. Necessary, sufficient. What follows from? Q follows from P. That was why the arrow went that way, yes? Q provided P. Well, again, that's where the arrow goes. So we have all of this sort of behavior. I want you to put a Post-it on this. If you've got the PDF electronic version of the book, put a tag on this page. We should keep this in mind when decoding, translating from English to symbols. Questions? So I have a conditional statement. If P, then Q. If you study, then you'll do well on the exam. I'm still using those two propositional values. Tell me, what's the English version of that statement.
If you did well on the exam you studied.
Okay, if you did well on the exam, then you studied. Tenses are kind of iffy because these are in present, and that sounds like it should be in past tense. English sucks. I'm going to say it over and over. What's the truth value column look like for this? Now, here's a problem. If I want to compare a truth table for this sentence with a truth table for this sentence, I need to keep the P's and the Q's in the same order. So, in this third column, there should be 3 T's and 1 F. Where? Emily?
The F would be the third one down and then all the rest of it.
Because remember, we're going Q arrow P. We're going right to left instead of left to right. And the only time this one is false when it's T arrow F. That happens here. Which means those two sentences don't mean the same thing. If you study, then you will do well on the exam means something different than I did well on. If I do well on the exam, then I study. Sounds weird. This is called the converse statement. And all it does is it reverses the places. But by reversing the places, you say something that is logically different. Okay. So I have a conditional. I have its converse. There are more ways I could play with this. Here's another statement. What's that one say in English? Same propositional variables. If I don't study, then I won't do well on the test. Again, I think that makes sense. If I study, then I'll do well on the test. If I don't study, then I won't do well on the test. This one says, if I did well on the test, then I studied. We know that those mean different things. What about this one? How would I make a truth table for this? Okay. I need to bring something into the game that I haven't talked about until right now. This is math. I need order of operations. What do I do first? The not or the arrow? I do the nots first. As a matter of fact, we'll write up a big hierarchy of order of operations in just another couple of minutes, but nots are always first. So in order for me to build a truth table for this, I'm actually going to do it in several steps. I can almost imagine that there are parentheses around these. So I'm going to do them one at a time. I'll make a not P table, and that just flips the T's and the F's. I'll make a not Q table. That just flips the T's and the F's. And now I can basically ignore the first two columns and just do my truth table looking at these. That's an arrow. There should again be 3 T's, 1 F. Where are they? Yes.
The second one.
The second row, F arrow T. But up here, F arrow T is a true statement. The only false up here is T arrow F. So the arrow itself is only false when the antecedent is true and the consequent is false. That actually happens down here in the third row. Hey, wait a minute. These two match. These two sentences mean the same thing. Because these match here, these are called logically equivalent statements. So our converse and our inverse mean the same thing. If you do well on the exam, then you studied, is equivalent to saying, if you didn't study, then you won't do well. Kind of freaky. Questions? Yes, sir.
That mean they both mean the same thing, or that just means they both make sense?
It means they mean the same thing. And that's the piece that's kind of weird to wrap your head around.
You repeat the sentence?
Yes. If I do well on the exam, then I study. That's this one. If I don't study, then I don't do well on the exam.
But they're both like, just that.
They are. I'm going to, because I'm basing this off of, if I study, then I will do well. So here I have two different ideas. The converse switches the order. The inverse flips the truth values, but leaves the order the same. Two different options. What if I do them both? I flipped them, I put the negatives in there, and I reversed the order. So what the hell does this say?
If I don't do well on the exam, then I won't study.
Although I think it would be past tense, right? I didn't study. Sure. Again, tenses are going to be weird because of the way it sounds in English, but bad exam, not study. I want a truth table. And again, because I'm going to try and do a comparison, I'm going to keep the P's and the Q's in the same order. So here's a case in the class where literally mind your P's and Q's. A short diversion. Anybody know the history of that statement? Where that sentence comes from? Unfortunately, no. Although I would like that. That would be a much more interesting statement. In the early days of the printing press, you actually physically had to put the reverse letters in a metal alignment. That's the original idea of movable type. You had little pieces that had the letters on them. And you kept them in boxes. And you kept all the capital letters up here. And you kept all of the small letters down here. So you had the uppercase and the lowercase. But they're backwards. Because you're going to take this thing and you're going to smash it on a piece of paper, right? That meant that the P looks like a Q, and the Q looks like a P because it's backwards. But you got to mind your P's and Q's, so you don't fall words. That's also where we get uppercase and lowercase from, and I thought that was hysterical. Dr. Jers over in the English department was a journalism major and a journalism instructor before he was a general English teacher. And he was the one who showed me that. He actually physically has movable type with his own weblog's title on it. He went to a convention, a conference, and they did that sort of stuff. All right, let's fill this sucker out. I'm going to need not Q followed by not P, so I can do the correct sentence. Negate the Q's. F, T, F, T. Negate the P's. F, F, T, T. Now I can ignore the first two columns and just work on the third and fourth columns. And I get, aha. I've seen that before. Which one is that? The original one. This sentence means this. Say that again. Oh, holy crap. Only I really didn't do two negatives, right? I only did one negation. I also did the reversal of the order, right? The reversal of the order was con, right? Converse. The name for this sentence is contrapositive or contraposition. And it means the same thing as the original sentence meant. So I have three different variations on a theme. I have the original, if P then Q. I have the converse, if Q then P. I have the inverse, which has the negatives in it, but keeps the order the same. And I have the contraposition. These two mean the same thing. These two mean the same thing. I was not the person who came up with these names. I don't know why converse or inverse or contrapositive are the names of these sentences. I'm just dealing with it just like you. On I could have sworn there was one table with all of these together. That must be in an older edition of the book. I apologize. I don't have it here. But if you put them all side by side, you see them match up. Questions? Yes, sir.
Are those like all of the ways that we can write it? It's only original, converse, inverse, and contrapositive.
Those are the only ways we're going to manipulate this logical condition. Yes. These are the ones that come up the most because in English, we say things differently. Remember, I said, if you study, then you'll do well on the exam. And we say, well, if you don't study, you won't do well on the exam. Technically, those don't mean the same thing. But colloquially, they absolutely do, right? If you study, you'll do well. The obvious connection to that is, well, if you don't study it. I had a student almost a decade ago who I saw 4 times in one semester. That's it. I saw him for day 1, exam 1, exam 2, and the final. He got D. The next semester, I saw him for day 1, exam 1, exam 2, and the final. I saw him in the middle 1 extra time because I moved the day of the exam and he wasn't in class to find out, so he came because he thought it was the exam. And I was still teaching, and then he got up and left. He got a B minus. Next semester, he got a C, and the next semester, he got a C minus. The semester after that, he actually got an F from me. He was cruising. I didn't need to study. I don't know this stuff. I could learn it from the book. Sure. Once. I've been teaching 30 years. It's happened once.
So with the logic statements, it's kind of like in philosophy when you do arguments.
And that is where this descends from. This is Aristotelian logic. It is designed to write those arguments, only I'm turning it into more algebra-looking crap so that I can try and make it mathier rather than verbal. Because the connotations in English are the part that piss me off. English, I don't know what language you're speaking. Words have so many different shades of meaning. P is either true or false, nothing else. If it's a proposition, that's it. I like this part much better than trying to do words. There's a reason I became a math teacher, man. Yet I'm teaching a history course with 6 papers in it this semester. Oh, well. More questions. I have one more, and then I promise I'll be done with making truth tables for a while, or at least with defining new truth tables. Now I've got a conditional statement that goes 2 ways. Okay, wait a minute. Let me go back to the English that's on page 7. If P then Q can be read P only if Q. So the arrow that goes from left to right on my screen is P only if Q. But the arrow can also be read Q if P. The arrow that goes this way says P if Q. So the way we read this is P if and only if Q. And what this really is a short way of writing this. If P, then Q, and if Q, then P. How do I know that those two mean the same thing? I could make a truth table for this and use it to define the truth table for this. So that's actually what we did when we first came up with this idea, is we said, okay, we're going to do P and Q, true, 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 false, false, true, false, false. If I was doing P arrow Q, I'd have a true here, right? If I was doing Q arrow P, I'd have a true here. So that works. If I'm doing P arrow Q, what happens? It's false. False and anything is false. If I'm doing P arrow Q, this is fine. But when I do Q arrow P, this is broke. When I do P arrow Q, F arrow something is true. When I do Q arrow P, isn't this what you wanted on Wednesday? This is what you wanted as an and statement. It's really not. See the difference here? You can fly out of Pittsburgh if and only if you've bought an airplane ticket from Pittsburgh. Questions? I already said earlier, knots come first. I want to put the not, the negation, at the top of my order of operations. Now I need to go in order of what gets more and more complicated. So second is an and, third is an or, which we could have exclusive ors there as well if we use it. We tend not to use exclusive ors as much as you might think. Then fourth is the implication, and last is the by implication. And that means if I remember order of operations, I can do away with extra parentheses. If you're unsure whether to do the or, I'm sorry, the negation or the implication first, you might say to yourself, oh, I should write it like that. Yes. But because you do the not before you do the arrow, this means the same thing as this. Okay. For some stupid, misbegotten reason, people in logic don't like using equal signs to mean logically equivalent. So they wrote an equal sign with 3 lines. I don't know who came up with this idea, but I want them to hit about the head and shoulders until they pass out. This is stupid, but there you go. I will use this. This just means logically equal. On the other hand, if I want to do the arrow before I do the negation, then I must have the parentheses. So which sentence I mean matters. Questions? Yes, sir.
What if the not, it's called a not?
The negation, yeah.
What if that was on the cue?
Same idea. If the not is on the cue, that is the same thing as P arrow, the negation of Q. The not gets done first, then the arrow gets done. And those are really the only places I could put it, right? It's either on the P, it's on the Q, because not has to operate on a single thing. It could operate on the result, right? Okay, hang on a second. This is a more complicated logical sentence. If I were to ask you, what are the truth values associated with this? Let's make a truth table and figure out what happens when we do this. We could do that fairly directly. I'll build it right from the T and F columns. So here's P, here's Q. And now I'll work the way the order of operations and the parentheses tell me to work. I'll do the arrow first since it's inside the parentheses. P arrow Q. But we already know from up here what the column should look like for that. What's our P arrow Q column look like? Seth? It's only false when the antecedent is true and the consequence is false. And then I say, oh, but I really need a negation outside that entire thing. So now I can ignore this. And I can say, oh, just flip what's here. Ta-da! Even if I have more variables involved. All of my operations only are unary or binary. So I never have to look at more than 2 columns at a time. Question.
What would the last column be in like terms of English?
Okay, each sentence is going to be different, right? So let me use study and not, right? So what does this read in English? If you study, then you'll do well on the exam is not true. I don't like that very much. We'll need to figure out a nicer way to say that. Translating into English is difficult. I'll do more of that on Monday, I promise. Other questions, please. If I have more letters involved, I'm going to have more options, right? So let's suppose I had 3 of these. I don't know what sentence we're making, but I just want to figure out what the startup looks like. How many options should I end up with? Before I even write them out, how many options should I have? Either any of these could be true or false. Yes? So P can be true or false. Q can be true or false. I know that when I did that, I ended up with 4 options. But that would mean that I could have this set of options when R is true, and I could have this set of options when R is false. So I'm going to need 2 sets of 4. Every additional variable doubles the number of rows in my truth table. If I had 6 or 7 of these, I'd 6 of them. 2 times 2 times 2 times 2 times 2 times 2. That's 64. That's a lot of rows, man. I don't want to do this. But in this case, how do I fill this out? I'm going to cheat and say it the way I did here. I'm going to start on the rightmost and flip it back and forth every time. Since I know I need 8 of these, I get those 8 options for R. Then I move over and I double. 1, 2 T's, 1, 2 F, 1, 2 T's, and 2 F's. I move over again to the left, I double again. 4 T's, 4 F's. And if you look closely, you'll see there's the 4 options I had to start with, right? And there they are repeated with all F's or with all T's. But I work from right to left building these. I promise there's a reason for that I will share with you a little later on in the method in which we count these. So I could now ask you to say, okay, let's figure out what it should look like for not P implies Q implies R. We'll be here a while, won't we? I got to make a not. I got to make that parentheses first. I got to do Q arrow R first. Then I got to make a not P column. And then I got to do those 2 not P arrow Q arrow R. So 3 things means 3 more columns, right? I'll do Q arrow R. I'll do not P. And then I'll do this whole thing. I'm not going to do that. You're welcome to if you desire. This is problem 39, part B out of the textbook. So you can look it up in the answer key because the odd answers are in the back of the book. Questions? Talk to me. Yes, sir.
So why do you like double it again? Like,
Okay. If I've got 4 options for just 2 letters, right? When I add a 3rd letter, I need those 4 options when it's true, and I need those 4 options when it's false. So I had these 4 options, right? I need it when this is true. I also need that same set of 4 options when this one is false. So I double it when I add the new letter.
Yeah, I was just asking what symbol that was. That's an X.
This one, it's a crappy looking R. R. I apologize. I know my handwriting sucks. That's why I use a fountain pen. It slows me down. If I was using a ballpoint, it'd be even uglier. My stylus writing on my iPad, no. Yes, ma'am.
So whenever, for this one, it just has 2 parts, so it's the, parentheses and then the not P. So you would do, just to make sure I know how to do an equation like this, you would do the not P's true or false, like, let's just say the first one, both of them are true. Just say both statements are true, I'm not even like, yep.
Well, actually, this would be a false, right?
Okay,
Right?
So-
Opposite P.
if we did those, it would be, the whole thing would be false.
F, arrow, T. F,
Oh, we didn't do the conditional, okay, gotcha, but just with that, you're just putting more things to it, I just wanted to make sure I know how.
that's why I'm gonna build it one piece at a time from the inside out. Build. I think that's the key word. I'm building these out of other pieces, right?
You're never gonna have more than 2 things for a true or false whenever you're doing it, like, you only have Q and R, like, if true, then, if Q, then R.
All of my operations either used 1 thing or 2 things. Nothing used 3. If I want to do 3, I have to build it out of 2s. So I could do P and Q and R, but I'd have to have parentheses somewhere. And we'll figure out how that works too. This is in here. How? Every single time I do a logic statement, I'm actually doing circuitry. I want you to take the letter T that you see here, and I want you to replace it with a 1. And I want to replace a false with a 0. And all of this just became binary computing. A guy by the name of George Boole thought this up and turned all of this Aristotelian logic into Boolean logic. Your Boolean variables in code are storing T and F as 1 and 0. I learned this with voltage. I want you to replace true with 5 volts. I want you to replace false with 0 volts, ground state. Pass electricity or don't. Physical circuit chips, transistors, of which there are 40 bazillion on a computer chip, do exactly this. On our Canvas page, there is a link to Texas Instruments chip library. And you can actually look up a computer chip and find out whether it's ands, ors, implications, all of it. It turns out we can build every one of these. Ands, ors, and so your computer chip really only has 1 type of transistor in it. And then we put them in different arrangements to make these things. If you're going to do hardware design, this is really what you're doing. On Monday, I'll tell you my defibrillator story. I built a defibrillator out of this stuff. That's where I learned this. In a pacemaker laboratory, trying not to make sure people died. But that's for Monday. I will see you all then. We'll do some translation between English and Geek Speak some more. Have a wonderful weekend, everybody.